will send the names. All right, nice. Online, you all hearing there? All hearing there online? All right, nice. So just to give you a quick idea of what module 1, 2, and 3 is and the way I'll be doing it, right? Because I don't really go 1, 2, 3. I'm gonna just give you a quick idea. So you have your module 1. Module 1 is complex numbers. No, I take it off. You could take off those 2 then. I'll put it back there. I'll all the remotes. Complex numbers. Complex numbers, differentiation, which is quite simple, and the hardest, integration. Okay. And then module 2 is your sequences, series, something like ABs and GPs, and then your roots. Right? How to estimate the root of an equation. Right? The third thing they're really easy. Module 3, on the other hand, module 3 is a topic that many people don't like, probability. Then matrices, really easy. And differential equations. All right. So that's what your modules will look like, right? All the videos, all your notes, all your past papers I will add you all to our Moodle site, and you'll get everything there as well, right? So you could always look back and revise and get your worksheets and thing there. All right. So these are your topics that will basically make up module 1, 2, and 3. Sorry. Yeah, lockdown says not really. Right, the order I will do it in is during the holidays. The plan is to do these 2 topics. When school be open, we do integration, differential equations, and then I'll probably finish up module 3 one time. So I'll do 5 and 6. And then I'll come here 7, 8, 9. Right? We're supposed to be done with this syllabus before around carnival time, so around February and thing. Right? It's normally finish this unit a little bit earlier. Right? Provided we cover enough in the holidays. So normally in the holidays, I'll do complex numbers and differentiation. Or at least complex numbers. Right? Differentiation kind of short, so I wouldn't really rush that. But as you ordered, that I'll do it in. The reason for that is that integration and differential equations, they're both linked. Right? So I'll do them one after the next. So you kind of do module 1, 3, and then 2. Okay? So we are going to start with complex numbers. Okay with that? Yeah. All right. Well, let's jump straight to complex numbers now. Let's jump straight into complex numbers. Right. So hoping all I could do are going to give you here. Head up complex numbers. Tell you what I can do this. No calculator. Well, at least not for the first part. So we can solve this, please. Solve 5x squared plus 6x plus 10 is equal to 2. Solve that, please. No calculator. It's pretty important. I'm going to assume already remember this. Use this here. X is equal to minus b plus or minus the square root of and tell me what's the problem that you encounter. All right, try and solve it in. And there's a slight problem that you'll encounter. I sent 1 or 2 in between, but I have yes, yeah. We fight against the pool.
Here? 1 year.
No, here. Somewhere right here, so I can't okay. Right here. So I have some of them like here. Here you know too. I've only put some mixed up, but I have like everything
Oh, no,
in
but
which is
what's that? We just see, but that's on Microsoft Notice.
well, I have it. I have all the images saved. So as I write, I save all the images. So I have all the images there.
But I have a program, it's the same thing. And it does it's in a PDF or that. So you take PDF, or you put it in a PDF.
Well, what I do is I go with this and I convert it to PDF. What this up. We're going to use a PDF. Export is convert all the text into PDF. But my handwriting is bad now.
So
Yeah, my handwriting bad, so for them to use it as the only source.
yeah, no, but like it was so, but like after class.
Yeah.
That's why I'm interrupted. You just don't need notes on Moodle. So you just then you computer might be no, but here. You get us wait that yeah, or wait us install it on the iPad.
Shucks. I get you. So you all see the problem? Square root of a negative. So complex numbers now allows us to work with those root of a negative value. All right. So watch this here. So we'll end up with x is equal to minus b, which is minus 6, plus or minus the square root of b squared, which is 6 squared minus 4 by a by c, all over 2 by 8. So that'll be minus 6 plus or minus the square root of how much you get here? 164 all over 10. Right. So when you reach here, how we're going to work with this is like this. X is equal to minus 6 plus or minus, sorry, plus the square root of, plus or minus the square root of 164 by the square root of 1. Remember this rule? Yeah? So we can factor out the minus 1 in our way. Yeah? And now we're going to use since I, right? The letter I represents the imaginary part of a complex number. So I is equal to -1, right? So we'll end up with x is equal to minus 6 plus or minus the square root of 164i all over 10. If you go to your Castle calculator and you plug that in, you're going to see something like this, but a simplified version. You will see those i's. So those i's represent a complex number. That's okay? So this could be written like this, right? X is minus 6 over 10 plus or minus root 164 over 10 I. Right? This x here is a complex number. Right? Instead of using x, we're going to use, right? And the complex number has two parts, a real part, and wherever the I is an imaginary part. So you have a real part and an imaginary part. Nice. Online, are you okay there, Rahul? Are you okay with that? Yeah. You can do what this first part you think. Jude. But the rest of them. Right, so today method you kind of try to start with, right? We'll do our first, we kind of have them. Of the pure one, they have a fit. Right, I think it's all. Oh. All right, nice. So we know what's the real part and the imaginary part. All right, so now we could easily move into how to represent complex numbers. All right, so complex numbers are generally, I'll tell you notes standard, right? So I know someone don't like to write notes. Right, so I'll send some of these notes out. Right, so complex numbers are generally, right, of the form z is equal to x plus I y, right? This is the real, this is the imaginary part. Right? X is the real part, y is the imaginary part. Okay, and I is equal to the square root of -1. So we need to know, besides I, we need to know what's I squared, what's I cubed, what's I to the 4. Right? What do you think is I squared? -1. What do you think is I cubed? What do you think is was I cubed? How you could represent that? What do you think is I cubed? Simple way to represent it. So it's minus. So it's this by this, right? When this is I. So we could say minus I. Yeah. Minus I. So I cube is minus I. What I to the 4th? What do you think is I to the 4th? Anybody online? Correct. 1, yeah, +1, correct. Benicia, you okay with this? Yeah, okay. So basically a complex number is going to look something like that. So what is I cube? I cube is equal to minus I, sorry, minus I. Minus I there. I cube is minus I. I forgot this was a double class, so I'll give you a small break in between, right? Right, so let's say I give it two complex numbers, C1, which is 2 plus 2i, and C2 is equal to 4 minus 3i. Okay, if I give it two complex numbers looking like that, right, we have to be able to add complex numbers. We have to be able to subtract complex numbers. We have to be able to multiply complex numbers. Right, well, I won't show you dividers. Okay, so let's say I ask you to add Z1 and Z2. So that's 2 plus 2i plus 4 minus 3i. Okay, whenever you're adding a complex numbers, all you have to do, add the real part, right? And add the imaginary part. So add the real, add the imaginary. And you get to it? So you'll be left with 6 minus I. That's okay? Right? Just to get your brain in a little motion there. See if we can subtract and see if we can multiply. This is subtract, this is multiply. See if we can subtract the two complex numbers and then multiply them. Then subtract and multiply. Take this. Ready? Let's see what the subtract look like, right? So that'll be 2 plus 2i minus 4 minus 3i. So this will be 2 minus 4 plus 2i is a minus and a minus, right? So that's a plus 3i. So I got minus 2 plus 5i. That's okay? Well, I should multiply. Two plus 2i, 4 minus 3i. So when you're multiplying now, when you're multiplying complex numbers, same thing, you just expand it out. 2 by 4, that's 8. 2 by minus 3, minus 6i. 2 by 2i, that's 8i. 2i by minus 3i, that's minus 6i squared. Okay, 2 by 4 is 8, 2 by minus 3, 2 by 4, 2i by minus 3i is minus 6i squared. Now, what do we know here? We know that 8 here is 8. What's I squared again? I squared is here minus 1, right? So that'll be minus 6 by minus 1. Minus 6 plus 8 is 2i. Okay. So we left to put what? 8 plus 6, which is 14. 14 plus 2i. Right, so we left with 14 plus 2i. Covered? All okay with that? So we need to remember those rules there, right? The I squared and when we do De Morse theorem, you'll need to know all those, right? Up to I5. No, I5 was fine. What's I5? What's I to the power of 5? I to the power of 5 is I to the 4th by I. Right? So you might need that, right? Take a squeeze in that. Hello, get there? Any questions online there? Jenna, you okay? Are you okay online there? Shabani? Yeah, all right. So next thing that we need to learn about is something called the conjugate. Conjugate of Z, right? So if Z is equal to X plus IY, it's conjugate. Then the conjugate of Z, which is written Z with a little hat on top or Z with a little star, is equal to X minus IY. Okay, so all they're gonna do is just change the sign in the middle. Okay. If Z is equal to minus 4 minus 2i, then the conjugate of Z, you're leaving the minus 4 by changing the sign in the middle. Okay, that's the conjugate of Z. All right, so sometimes we need to learn about the conjugate of Z. Oh, I want some feedback from the exam from all them. No question here. No, I want to know how you all felt like in preparation wise. But I want to do it specific to questions. So I'll do the question and answer. I'll select a little Google form for to answer. Right, so generally, anybody can tell me what it thinks Z by Z hat is? What do you think is z by z hat? When you multiply x plus iy by x minus iy. What you'll get all the time? Anybody? Try it and you can expand if you want. What you're going to get when you expand that out? Take your time. Try and see what you'll get when you expand that out there. Right? Anybody online can message if you want. What do you think you're going to get there? All right, let's see if anybody sent anything there from I'll give you something general. Nice, general. Yeah, correct, Rahul, correct. Kilon, Jada, you're close, just check back your sign. Right, Nathaniel, you close as well, check back your sign. What you all got here? You expanded? Continue now, continue. Very good. Go. Very good. Minus I or I squared. Minus I squared, right? Minus IY squared. IY, right, IY all squared. So that's I squared, Y squared. And I squared is what? I squared is -1. Yeah. Right. So when you expand this out, x by x, that's x squared. X by minus IY is minus IXY. IY by x is plus I by XY. And this here will be minus I squared Y squared. This will cancel. And you'll get x squared minus I squared is -1. Minus and a minus a plus. So again, x squared plus Y squared. Okay, so we get x squared plus y squared. That's what you'll end up with. So generally, z by z half is that. So, right? If we have to divide two complex numbers, here just if you have to divide two complex numbers, what you'll recognize about x squared plus half y squared? Any imaginary thought? No. So basically, this is real, right? So if you have two complex numbers and you want to realize it or like rationalize, get rid of the square root, you want to get rid of the I underneath here, what you just do is multiply by the conjugate of Z2. Right? By doing that, this by this will give you something real. Right? So you end up kind of realizing the underneath, convert it from imaginary to real. Okay? So it's important that we understand this here. C by z hat is x squared plus y. So to divide it is what we're going to do here. I'll show you an example now. Ready? So watch this here. Example 1. How do we work out this? It's a 5, right? 2i plus 3i over 5 plus I. How do we work out a complex? How do we simplify that? You're going to multiply this by the conjugate of the denominator. The denominator is 5 plus I, so the conjugate is 5 minus I. Okay? 5 minus I. Okay with that? And then you work it out. So you'll end up with 2 plus 3i by 5 minus I on top. Underneath, you will end up with, just use the rule, don't multiply it out. This is x and y is 1. So you're going to get 5 squared plus 1 squared. Don't multiply it out, right? You'll get x squared plus y squared. This is x and this is y. Right? And then you simplify top part. So you'll get 10 minus 2i plus 15i minus 3i squared. All over 25 plus 1 is 26. So this is what 10 I squared is minus 1, minus and a minus or plus 3 plus 10, that's 13. Minus 2 plus 15 is 13. All over 26. Yeah? Yeah? Okay with that? Any questions online there? You all okay with that there? Sure, okay there, Rika? on the channel, the part underneath, I use the rule underneath, right? I use the rule here. Z by Z conjugate is always x squared plus y squared. So I multiply this by this, and I have x squared plus y squared. So I just use the rule. If you do it the long way, it will simplify just so what we have here. Remember, we got I squared is -1, a minus and a minus gave us a plus. So this rule will always hold. Z by conjugate is always x squared plus y squared. All right. Right, so this rule here will always hold. Are you okay with that? Yeah? Try this here, come on. Simplify that, please. Right, take a time, message answer, and then let's move on from that, right?
This would come where I from the one and this minus 23. Where I that's all I say. Just put I right there and everything.
Nice, Jenna, looking correct. Rika good, Varun good, Elon good, Rahul good, Shavani good. Check back your sign, Nathaniel. Right, check back your sign. Police have physics lessons online. What he's used? Huh? Meets. All right, nice. Let's see what we got. So you multiply by 4 minus 3i over 4 minus 3i. The denominator is 4 squared plus 3 squared. The numerator is 5 by 4. 5 by minus 3 minus 2 by 4 minus 2 by minus 3 is positive 6i squared. 16 plus 9, that's 25. You have 20. This is I squared, so that's minus 1, that's minus 6. Okay, minus 15 minus 8i. 20 minus 6 is 14. 15 minus 8 is 23i. Okay, and then I divide everything by 25. Any questions online? Anybody? Tunisia, again, sure. All right. Let's just try a small past paper in this. Small meaning just a little part. Going on there. See that go? Huh? Yeah. Camera giving trouble, right? I like it taken photo. Okay, I don't know what's going on there, no? I would just share it here. I would just share the full paper. All that just for you to do Z3 divided by Z2. How did I do that? Why get 400 or something? Hello. 1, 2, 3, 4. It's 50 a section. And what get on? What's section? What's it? Oh.
No,
A little bit less because of more sessions. Right. I would normally charge like 50 a session. But no, but I know see because it was 10 session for the sake of that. So I will go.
Nearly how much?
I got you. Remember it's Z3 and Z2, right? So it's supposed to be easier, right? Yeah. Trouble? So it's minus 2 plus 2i over root 3 plus 3i. You can just have a little square root to deal with. It just have to deal with a little square root, right? Right, so let's see what we got. So it's minus 2 plus 2i all over root 3 plus 3i. So you multiply by the conjugate, which is root 3 minus 3i all over root 3 minus 3i. Your denominator here will be root 3 squared plus 3 squared. Right? And the numerator will be minus 2 root 3 plus 6i plus 2 root 3i minus 6i squared. So underneath here will be 3 plus 9, which is 12, right? And you'll get minus 2 root 3 plus 6 plus 6 plus 2 root 3 by I. So it mightn't look too good. It's not looking too good at all, but 2 root 3 plus 6 over 12, you can break it down a little bit if you want. Plus 6 plus 2 root 3 all over 12i. Anybody get that? If you want, you could actually work this out. Huh? Time enough. Oh, got that? You good? Anybody got that one line? Of course, you can simplify the little parts in bracket if you want, right? And you could put the value in decimal if you want. How much is that in decimals? passing brackets, how much it is? If you work out the passing brackets, how much you get? In your calculator, not in your head. So 6 minus 2 root 3 and 6 plus 2 root 3 all over 12. By the way, where from? Huh? Oh, you put C1 and C2 and C3 in the wrong place. And with every decimal. 0.211. 0.789. Right? So you can also get that. You don't want to leave your answer like that, yeah? But I just saying, right? In case some of you will kind of simplify it out. Are you okay with us? So that's just the introduction into complex numbers. Hey, for the 10 minutes and 25 seconds again. Right? So there's the intro into complex numbers, right? So the next thing I want to do is I want to give you a feel of what a full unit two, not full, but what a unit 2 question might look like, a lot of working. Right? What you will recognize in unit 2 is that the questions may not necessarily be hard, but to earn like 4 or 5 marks is a page long or 2 pages long. It's a lot of working. All right. So I want to give you an example of one like that. Right. So these questions are going to take a little bit of time, but they're not difficult. Okay. One of the problems with unit 2 exams is after trying to finish the exam. Because of how long it is, sometimes people don't even finish. This year was a little kind of hardish exam too. All right, nice. Let's go back. I'll give you a small break just now, right? After this one. I'll give you a small break. And it's till 5, right? It's 5 or half 5. No, it's until 5 or half 5. 5. Okay. So the next thing that you want to look at a little bit long is to find the square root of a complex number. All right. So head up square root of a complex number. Do you also have any pure in school? No, sir. You also have pure in school. Was that pure in school? Unit 2. Well, let's start in the unit 2, right? So I'm bring on it for a week. All right, so let's take a look at how to find the square root of a complex number. So I just gonna give you an idea of what we're going to do before I actually do our example. So what you say? If I say, okay, well, here's what, find the square root of 2 plus 3i, right? The square root of a complex number is always going to be a complex number. Okay? So if I square root this, I'm going to get about this. So our objective now is to find x and y. So one of the techniques to find x and y is to actually compare both sides, like square both sides, together the square root, and then compare the real part and compare the imaginary part. And we'll get 2 equations that we solve simultaneously. Right? To find x and y, we need two equations. How we get in them? Square it, compare the real, compare the imaginary, and then we work it out from there. That's okay. So I'm going to show you that. Let's take a little while, a little bit of work. All right, so I'll show you by an example, and I'll give you a little small motion screen, right? So let's start with the next example. Right? And in the example, right, I want you to notice that the square root of a complex number is always equal to a complex number. Let's call it C. All right, so if I ask you to find the square root of 2 plus 3i, we're going to make it equal to some arbitrary complex number, x plus yi. If you want, you could write yi or you can put the I in front, right? It don't matter. So if we square both sides, we're going to get 2 plus 3i is equal to x plus y I squared. Right? You're going to square all of that. This is 2 plus 3i is equal to, when you expand this out, you're going to get x squared minus y squared plus 2xyi. In case you're not seeing it, x plus iy, x minus x plus yi. When you expand this out, x by x squared, x by this by this by this. Right? X squared, this is minus 1, so you'll get x squared minus y squared plus 2 of this, 2xy. That's what I have here. Okay with that? When we compare both sides now, when we compare both sides, we will see that the real part, the 2 is equal to the real part here. This is the real part, right? So 2 is equal to x squared minus y squared. And the imaginary part, which is 3, is equal to 2xy. Okay with that? You see enough? So we have equation 1 here. This is always going to be equal to this, and this is always going to be equal to this. And here we can see that y is equal to 3 over 2x. Okay, this is our equation 2. We can solve them simultaneously now. Copy down and let's solve it. That's true. So we solving it, right? So we're going to substitute equation 2, equation 1. So we're going to get x squared minus x squared minus 3 and 2x all squared is equal to 2. So this will be x squared minus 9 all over 4x squared is 2. What are you going to do here? Here the fraction. So you're going to multiply by 4x squared. So we're going to get 4x to the 4th minus 9. 4x squared here will give you 8x squared. Bring it across. So we get 4x to the 4th minus 8x squared minus 9. Okay? This guy is quadratic, so when you solve it, you'll get x squared or something. Everybody get check it. Solve the calculator now. All right, so I'll substitute y here, I'll square it out, I get rid of the denominator, and I'll solve. Any answers? What you got for x squared and y for x squared? Right, just solve it like a normal quadratic, right? You can let y equal to this, so this is y squared. How much? Not that's converted. 2.8. And here is what? Minus 0.8. Right. So x and y have to be real. Right? X and y are real. So here, although we're doing complex numbers, this is no real solution. Right? We don't want this because x and y have to be real, right? We want this. X is the square root of 2.8, which is square root of 2.8. How much? 1.67. Nice. So we know what is x. We have to go and find y. So therefore, y is equal to 3 over 2 by plus or minus 1.67. And you will get your y back. So how long it is? I sure someone done log out already online there. Right? And that's about 3 questions. Sorry, about 3 marks. Sorry, 4 marks. That's this and the next part will be like 7. Right up, please. What you got here? 0.89. So your final answer is that the square root is equal to z is equal to plus and minus 1.67 plus 0.896. Right? Put the plus and minus on the outside, right? That's what it looks like. Any questions online? All right, there still? Jude, all right, there still? It's a little bit long, I know that. Varun, are you okay? Adam? All right, so I'll give you one lesson, all right? Take a little break. Take a little 10 minutes. And then we start back right here. All right, take a little 10 minutes break and then we start back right here. I'll give you an actual past paper. All right, so in 10 minutes, we'll start back, right? All right, let's start back here, Olia. Let's jump into our past paper, right? I'll take a picture and then I'll have to share it. All right, so let's find the square root. Find the square root of minus 15 plus 8i. This is 2009. It's not as much marks now, but I'll show you how much marks for it, right? Oh crap. Oh, it's root teeth right here. Right, look at it. It used to be 7 marks, not as much now, it's about 4 now. Huh? Try that there for me. Find x and y. Notice the question said x and y are real numbers, right? Take your time and solve it, right? One answer. Tyler, yours already? Your answer already? Yeah? Not sure. Now, whole number. Check it back and see. Think the answer is a whole number for X and Y. I'll do this now. Swear. Wait a minute. Okay, so actually 4 here, right? That's Keelan looking okay, Rahul looking okay. I just think one of the values back to form, but I'll check it as now. You didn't get whole numbers? I'm not sure now, I'm not sure now. I think it's supposed to be whole number. Because there's a part one is about the question that has, you gotta use this in part two, so most likely it's whole number. Right, message answers, I told you. Let's see what you got. All right, let's see how it went. Right, you'll just help me solve the quadratic, right? So u squared minus 15. So u squared is equal to minus 15 plus 8i. So if we let u equal to x plus iy squared, that'll be minus 15 plus 8i. This will be same thing, x squared, which is x squared minus y squared. We have the x squared plus y squared, or minus. X squared minus y squared plus 2xyi. So when you compare, we have x squared plus y squared here. So when you compare, you'll get x squared minus y squared is equal to minus 15. 2xy is equal to 8. Right? So y is equal to divide everything by 2. That'll be 4x. Okay? This is your equation 1. This is your equation 2. So we're going to substitute 2 and 1. So you'll get x squared minus 4 over x squared is equal to minus 15. So we'll end up with x squared minus 16 on x squared plus 15 is equal to 0. Right? Multiply everything by x squared. So we'll get x to the 4th plus 15x squared minus 16 is 0. When you solve, you'll get x is 1. Yeah? You'll get x squared is 1 on what? 16 minus 6 minus 16. This has no real solution. So x is equal to plus and minus 1. Okay? So you can solve for y. Y is 4 over plus and minus 1, which is plus and minus 4. So the complex number u is equal to plus or minus 1 plus 4 by I. Okay, so you could write it like this, or you could write it like remember, it's two separate complex numbers, plus and minus. So you see a little mistakes. You got this second time. Any question online? All right, last one, then I'll show you how to use them in a question. Right? Why you need to find the square of a complex number. Anybody writing there? Kelsey all again, should I? Instead of splitting up class Friday and Saturday, I think I would have done pure Friday. Like at 4 hours and 4 hours Saturday. So in the dominated Friday. Or split it up 2 and 2. Anyone? Or you can decide, right? If to put like a 4 hours, instead of doing 6 hours, just do 4 and no, an hour, just finish up with that. Should be all right with 4. Right, so let me know if to put 10 to 2 Friday or split it up. 10 to 12, 10 to 12, Friday and Saturdays. Or you can decide, right? All right, so good. Let's just do one more. And then I wanted to combine this into the last part of the question, right? Right, find the square root of minus 2i. Find the square root of minus 2i.
This is the real part. Yeah. The part in front is the real part. But you do have a real part here. Right, that's 0. And 2xy is minus 2.
Last 2 minutes, right? Again, whole numbers, huh? Should get nice whole numbers. plus and minus 1 for x, and y will be minus 1 over plus and minus 1. So that'll be minus plus 1. The other way around, right? Because when x is positive 1, y is negative. When x is negative 1, y is positive. So it's minus and plus. Okay? So here's what I'm saying, right? When x is 1, y is minus 1. So that complex number will be 1 minus I. And then when x is negative 1, y is positive 1. So it will be negative 1 plus I. Okay? So you can write it like that. Or I like to write it combined. It'll be plus and minus 1 minus I. What should get and say? When it's a positive, you'll get positive I minus I. When it's a minus, you'll get minus I plus I. Okay, nice job, Kilon. All okay with that? So get in the habit of writing the answer like this, right? Combine. Everybody okay with us? All right. Yeah. Trouble? Trouble? Like if follow your mistake. Any questions online? Jenna, are you okay with us? Nathaniel? Oh wait, Nathaniel should both. You okay?
That's nice to hear.
Right? What you have to get used to in unit 2 is doing this in about 2 or 3 minutes, right? That's how much time you'll have. Yeah. All right. So why are we doing this? Well, what we need to be able to do is to be able to solve a complex quadratic. Okay. So in some point when we solve the quadratic, we are going to get this. Remember, b squared minus plus or minus square root. We are going to end up with something like this, right? So I'm going to give you a complex. So x squared minus 2x minus 4 equal to 0 or plus 4. This is a real quadratic. It's not complex, right? But it might have complex solutions. If the coefficients are these values, like a is 1 here, and b is minus 2, and c is 4. Suppose it had something complex like this. A is 2, b is 2 plus I, and c is 3 minus, and c is 3 plus 2i. That's something like that, right? Let's say it has something like this. When your coefficients are complex, right? When your coefficients are complex, you're going to end up with a complex quadratic looking like this. 2z squared, right? So instead of using x, you're using z now. 2z squared plus 2 plus iz plus 3 plus 2i. Right? And then we have to be able to solve it. The thing is, we're going to solve it the same way. Z is equal to minus b plus or minus the square root of b squared minus 4ac all over 2e. You're going to solve it like normal. But the problem is here. But the difference is here. When you solve it, you're going to get the square root of a complex number. So that square root part will be something complex. And then you have to use what we have here to get the square root of that value. Okay? Expand over again. So you're going to get, so now we're going to change it up a little bit. Initially, you had A, B, and C being real values. And then you solve the quadratic, and you might get a complex solution. But now I am going to give you A, B, and C as complex values. So now you're going to get this here, a complex quadratic. Right? So instead of using X, you're using Z now. And then you have to solve it the same way. Nothing will change. You're going to solve it the same way. But the problem is, see right here, the square root part. Yeah, you're going to get something like that. Square root of 2 plus 3i. Right? We're going to give you something like this, square root of 2 plus 3i. And you have to put it out. And get the square root. Okay, and when I get it now, you take off this and put this. All right, so next, last heading, solving complex quadratics.
All right, thank you.
Solving complex quadratics. When you say you're doing okay?
I give you a minute.
Hmm?
Yeah, it's not okay. I
Somewhere there. Okay, I never shared in the group. I will share. Yes, all of it, right? All right, so take a small little note to solve a complex quadratic. To solve a complex quadratic, of the form az squared plus bz plus c az squared plus bz plus c is equal to 0, where a, b, c are complex. Of course, not all complex. Once one of them complex, at least one. Right, we use z is equal to minus b plus or minus the square root of b squared minus 4ac all over 2e. Right, so to solve a complex quadratic of the form az squared plus bz plus c is equal to 0, where a, b, and c are complex, we use z is equal to, and we'll be using normal formula, right? Full stop. To simplify the above equation, we generally have to find the square root of a complex number. We generally have to find the square root of a complex number. Ready? So go and save some time. I'm gonna give you one that we kind of already found the square root of the complex number already. So let's try this example here. Example 1, right? There's 2 examples and we're done. Right? Example 1, let's see if we could find the roots of z squared minus 3 plus 5i by z plus 8i minus 4 is 0. Z squared minus 3 plus 5i by z plus 8i minus 4 is equal to 0. All right, so let's start to work this one out. A is 1. B is equal to minus open brackets 3 plus 5i. Leave the brackets, right? And C is equal to 8i minus 4. Right? Then we're going to substitute. And Z is minus B plus or minus the square root of B squared minus 4AC all over 2E. Take your time on the substitution. So you'll get Z is equal to minus minus 3 plus 5i plus and minus the square root of minus 3 plus 5i all squared. So all the minus signs will cancel off. Hope you're seeing that, right? Minus 4 by A by C. 8i minus 4. All over 2 by 1. So we'll end up with 3 plus 5i plus and minus the square root of 9 plus what? 30i. So I just squaring that part there. Plus 25i squared minus 32i plus 16 all over 2. You'll see that there? So I just square this out for you. 3 plus 5i by 3 plus 5i. I got 3 by 3 is 9, 15 and 15, 30i plus 25i squared. When you simplify it, you should get 3 plus 5i plus and minus the square root of 9 minus 25 plus 16 plus 30i minus 32i all over 2. So that'll be 3 plus or minus 5i. Sorry, 3 plus 5i plus or minus the square root of 9 plus 16 is 25 minus 25 is 0. 30 minus 32 is minus 2i all over 2. What was the square root of minus 2i again? I can see. As we just work out plus and minus 1 minus I. So take this off, and you'll get and replace it with 1 minus I. Right, for those who get lost, I just going into a fast for you. All right, and in blue, I took out what is A, I took out what is B, I took out what is C. All right, then I plug it into the normal quadratic formula. Substitute B, I substitute B, I substitute A, I substitute C, and A again. And I take my time and I expand this out, and I got this value here. I multiply minus 4 out here, and I got this value here. And simply brought the real part together, brought the imaginary part together, and I end up with minus 2I. Right? And we already know that the square root of minus 2I is 1 minus I. That's it. We got to go. Right? We have one more part, but I will do it on the next slide. That's now. Okay, but we're not done. I just going to turn the page, right? So this will be equal to 3 plus 5I plus and minus 1 minus I all over 2. So we have to finish it up. 3 plus I, 5I plus 1 minus I all over 2. And then we have to do it 3 plus 5I minus 1 minus I all over 2. 3 plus 1 is 4. 4 plus 4I on 2 is 2 plus 2I. On this side, 3 minus 1 is 2. 5 minus 1 is 4. Sorry, plus 1, that's 6. So I got 1 plus 3I. So your solution there is 2 plus 2I, 1 plus 3I. Yeah, very long, huh? So imagine I give you a question to solve, and then you have to go and find the square root of the complex number. And that was how much marks? That was 8 marks for all of that. Everything was 8 marks in total. So can you go back to the last year? I'll go back just now. Just give me 1 second. One more and be done, right? I know I now probably first time I'll do pure math since paper 1. Go back here. You got you there? All right, nice. Are you okay with this? Yeah. All right, just one more and we done. Oh, that last year was this 2009, I think it was. This one is 2000. Oh no, this one's 2009. All right, solve this here, please. C squared minus 3 plus 2i by c plus 5 plus r. Last one. Take your time, right? I gave you the square root already, so you don't have to go and do over the square root part, right? Yeah, solve that. No, yeah, I gave you the square root part already. When you work it out, you will see. When you work it out, you will see. You're supposed to get the square root of something that we did already. Check by your just now sleep. I'm not too sure. Yeah, you all got minus 15 minus 8i. And it's square root part, sorry, plus 8i. Yeah, and it's square root part. Right, finish it up quick and we're done. What was minus 15 plus 8i again on it? One plus. Okay. All right, nice. So let's make it substitution and good to go. All right, nice. I've seen some good answers. Did you check back your first answer? It's the second part looking. Check back your sign actually. Rana, yours looking good there. Jenna, very good. Yours looking good. Shabani, good.